Question number 49. The voltmeter shown here reads 18 volt across this 50 ohm resistor. Find the resistance of the voltmeter. So the voltmeter reading will be slightly less than the actual reading because of the resistance of this voltmeter. We need to find out that resistor. So let us say that voltmeter resistance is something like R, and then we are given that the voltage across this is 18 volt. We are given that the voltage across this point is 18 volt, and 30 and 24 volt ohms are 30 volt battery and 24 ohm resistance are given. So let us assume that this resistance R equivalent is Req, and with this 18 volt given, it is easy to calculate R equivalent. Another way to solve would have been to first find out the equivalent resistance, R into 50 divided by 50 into R, and then find the then use a voltage divider formula, but then that would complicate. So you can solve that way also, or maybe you could also solve using a Kirchhoff voltage law in this loop and in this loop. There are many ways you can solve this equation, but this is just one way. So R equivalent here can be found by this voltage divider. This 30 volt gets divided across 24 volt ohm and Req, and that division will depend upon the relative values of 24 and Req. So the voltage across this will be 30 volt multiplied by Req divided by 24 plus Req. And from here, you take whole this thing here, 18 into 24 plus 18 into Req, 80 from 13 into Req minus 18 into Req becomes 14 into Req. So this goes to the right, and we have 30 minus 18 as 12, and then that 12 into Req, take 12 to this side, becomes 18 into 24 divided by 12. 12 into 2, 24, 18 into 2, 36 ohm. So we know that the equivalent resistance of 50 ohm and R is 36 ohm. And then we can use this formula 1 upon R equivalent is equal to 1 upon R plus 1 upon R1. 1 upon 50 plus 1 upon R. 1 upon R is 1 upon 36 minus 1 upon 50. 50 minus 36 divided by 36 into 50. If this gets divided by 2, 2 into 7 is 14, 2 into 18 is 36, 18 into 5 is 90, 900 divided by 7, 7 1 times 7, 2 0, 7 2 times 14, 6 0, 7 8 times 56, 4 0, 7 6 times 42. So this is roughly the answer. Okay, the one thing that you need to keep in mind that this resistance is comparatively high compared to this resistance, and therefore, for example, if there were no resistance here, the voltmeter would have been reading, the actual resistance would have been 50 divided by 50 plus 24, let us say 25, and then multiplied by 30. This is 2, this is 3, this is 10, this is 20 volt. So the actual voltage would have been 20 volt, but because we added a voltmeter here with comparable resistance, a part of the current start flowing here. The current in this one gets reduced, and also the voltage across this. Therefore, the voltage across this is reduced, and that reduced voltage is read by the voltmeter.